Hey, welcome to our very first lesson in geometry. The lesson we're going to be learning about the most basic terms in all of geometry, points, lines, and planes, along with some other terms that are going to be important to know. I'm going to just point out right away, because this is a very first foundational lesson, we need to develop a whole language for talking about geometry. And because we're developing a language for talking about something, this is going to be a very terms-heavy lesson. The first several lessons are going to be very terms-heavy. So buckle up and get ready. You are going to need to understand the definitions of a lot of terms. It might be a good idea to have some note cards on hand and put some definitions on the back of note cards to help yourself learn better. Whatever it takes for you to understand definitions better and be able to develop a vocabulary for talking about geometry. Now, I say this lesson is about points, lines, and planes, but actually we're not going to get there quite in the first video of this lesson. It's going to take us a little bit to work our way there. The very first thing I'm going to talk about is the founder of geometry. The person who started it all was this handsome fellow, Euclid, who lived back in around 300 BC. Euclid wrote a work called The Elements, and in Elements, he laid out all of these geometric proofs, doing something that had really never been recorded before, at least to our knowledge, before the time of Euclid. He tried to develop an entire mathematics using two tools. The tools he used were a compass and a straight edge. Now, these are the modern day equivalents that we're going to be using this year as we do some Euclidean geometry. But these are unlike the tools that Euclid would have used. I'm going to spend a little time talking about the difference between Euclid's original geometry and our geometry of today. Okay, so Euclid's straight edge was made for drawing straight lines, but it wouldn't have looked like this because ours has measurement on it incorporated as well, inches, centimeters. Euclid's wouldn't have had any measurement units on it. It would have just been a straight tool for drawing straight lines. Same is true of his compass. His compass would have been a tool for drawing arcs, but it wouldn't have had any degree measures on it. There was no measurement on it. Our compasses are probably going to have measurements on this curved piece right here to tell you what the angle measure of the arc is that you're making. Euclid's would not have had that. Okay, now I'm going to just spend a moment talking about this. You are expected to have a compass and a straight edge. Sometimes we're going to use them Euclideanly, okay? And we are going to be just using them as a arc circle making tool and a straight edge. Sometimes we're going to be using them for measurement, though. Be aware. And we're going to add a third tool to our repertoire that we're going to be using this year. We're also going to be using a protractor. I'm going to say this. Your ruler and your protractor can be cheap, chippy cheap. Okay, you don't have to spend a lot of money on them. But your compass, you should go to a place like Staples, find a manager and say, "Excuse me, sir, could you show me your second most expensive compass?" You should get a good compass, one that's made of metal and that's able to hold a shape even when you take your fingers off of it. And that's going to be very good for you when you're drawing circles or arcs with a compass, because then you won't lose your arc measure, okay? Don't get a plastic compass, a cheap plastic compass, because it will forever be sliding around on you and you'll be losing your arc measures, and you're going to be very frustrated when you can't get your constructions to work correctly like you're going to need to. All right, that's my little rant there about having a good compass. Make sure you take that advice. Now let's talk a little bit more about Euclid. Euclid's geometry is a little bit different from modern geometry in some key ways. Euclid was a very practical guy. The Greeks were very practical people. And Euclid would have envisioned geometry and the figures that he was making as actual real figures that he could really make. Let me give you an example of this. So what is a line? You may have learned that a line has to be a straight figure that extends infinitely along one dimension. So a line is one direction, another direction. Okay, so it's a straight line. When you draw it on a page, you're going to start at a point, draw a straight figure to the right, and then along that same figure you drew to the right, you're going to draw a straight figure to the left. Okay, and it's going to be this thing that has length that extends infinitely in either direction. Euclid wouldn't have had a concept of the infinite. He would have drawn a line in the sand using a stick. And since he can't draw an infinitely long line in the sand using a stick, all of his lines would have starting and ending points. So to him, a line was something that had a starting and ending point. Today, in our pure mathematical approach to geometry, we would call that a line segment. But here's the other thing Euclid would have done. If he made a curved figure that started at one point and ended at another point in the sand, he put a stick in the sand and drew this curved figure from one place to another place, he would have called that a line too. Then he would have differentiated that from the straight line by calling it a straight line if it went straight from one point to another. Or in Euclidean terms, it might have been called a right line if it went from one place to another directly. The same is true of planes. We're going to talk about planes in this lesson as surfaces, like flat surfaces. Well, to Euclid, he would have gone out and stood in a field and seen that the field has hills and valleys and slopes, and he would have called that a surface or a plane. And he would have differentiated it from the perfect mathematical form by calling the flat plane a right plane. Today, we would define a plane as already being flat or right, like this perfect geometric idea that we have. And we would also say that it extends infinitely in all directions, at least in its dimensions, where Euclid wouldn't have really defined anything as being infinitely long. Then just one other thing. We have an entire mathematics these days based on things that are infinitesimally small. Points, the smallest possible things, and you can add together a lot of infinitesimally small things to get sums that help us understand more complex geometric figures. I don't even know what to call it geometric at that point, but that math that we do that with is called calculus, and we're not going to be learning any calculus in this class. So sometimes when I say calculus, people get really afraid. It's a fear-invoking term, but don't worry, we're not doing calculus in here. But we have that mathematics where we've talked about infinitesimally small pieces that we add together. Euclid would have had no conception of that in 300 BC. So he doesn't spend a whole lot of time talking about infinitesimally small things, except he does note that a point has no dimensions, no length, width, or breadth. It's infinitesimally small, even smaller than that because it's nothing. It doesn't have dimensions. Okay, so Euclid kind of would have been able to conceive that, but we've built entire branches of mathematics off the infinitesimally small and the infinite, and those aren't very practical things to think about. Euclid was a much more practical mathematician in that he would be able to relate this geometry to real world things a lot more, although he was building a theoretical geometry removed from the real world as he was writing Elements. Okay, so it's kind of important to realize that distinction. We've developed a lot more of that abstract math since the time of Euclid. Maybe that's the best way to put it. Okay, so let's talk about our first definition. And believe it or not, our first definition is the definition of the word definition. And I'm going to take a moment to say this. The definition that we're going to be defining here, oh, this is already confusing. The definition that we're going to be defining here is different than the word definition as it refers to like the dictionary definition. We're going to be talking about a mathematical definition. In fact, we're going to be specifying this is going to be definition in geometry. And what does definition refer to in geometry? A statement that defines a mathematical object. Now, I absolutely hate when definitions of terms, like the word definition. Notice that definition is based on the word define, okay? Notice that define is also over here in the definition of the word. We call that a circular definition. That's the way Saxon decides to define the word definition, and I hate it. I hate circular definitions. But I think I can help you overcome the problem with this in just a moment, so bear with me. We're also going to define an undefined term, and that's going to help us wrap our heads around this one. An undefined term is a term that is not defined using other mathematical terms. Now I'm going to say this, in geometry, we need some undefined terms. We need some basic terms that don't have to have definitions themselves, but that we can use to define all of the other terms in geometry. I want you to picture undefined terms as building blocks. These are our building blocks of geometry. And we're going to define terms based on our most basic undefined terms. Another way to think about this, though, is to consider the word undefined in a way that you've used it before mathematically. Okay, so here's the way we've used it. Do you ever remember doing this? What's the slope of a line? Slope of a line is rise over run. Okay, so what if we have a line that has a rise of 9 and a run of 0? What is 9 divided by 0? I can't divide 9 by 0. That number would blow up to infinity immediately. So you know what we do? We say that this slope is undefined. It doesn't have a reasonable dimension, okay? And that's what undefined means in the case of undefined term and in the case of a definition. So definitions mean that we can actually measure things to describe them. Undefined means that we can't measure them to describe them. That means at least one of their dimensions doesn't exist. Okay, now that sounded confusing. If this is all very confusing to you, that's fine. If you're a mathematical thinker, maybe this made some sense. If you're not, I'm going to give you a little hint here, make this very concrete. There are 3 undefined terms in geometry that you have to memorize. You have to know that these are the 3 undefined terms. Okay, if you can do this, then so far this lesson is making sense to you. They are point, line, and plane. Those are the 3 undefined terms in geometry that we're going to be talking about in the rest of this lesson. So that's the end of this first video. Next, we're going to pick up and look at the actual definition of our undefined terms. And when I say definition there, I'm using definition like dictionary definition. But since the terms are undefined, they don't have a measurable definition. And that's what we're going to be getting into next.